Hello friends, in this lesson, we are going to learn the concept of peak factor, also known as crest factor. First, look at section number 1. Labeled definition. In this section, the basic definition of peak factor is presented. Peak factor is the ratio of the maximum value, or peak value, of an AC quantity, to its RMS value. In simple terms, this factor shows how many times the peak of the waveform is greater than its RMS value. Also, in the key idea box, an important point is mentioned: the larger the peak factor, the greater the difference between the peak value and the RMS value. Now we move to section number 2, the waveform reference. In this part, a sine wave is shown. As you can see, the wave has a positive half cycle and a negative half cycle. The highest point of the wave is called the peak value, or maximum value, while the RMS value is derived from the entire cycle of the waveform. In fact, the peak factor defines the relationship between these two values. Now we move to section number 3, the formula. In this section, the main peak factor formula is shown. Peak factor is equal to the peak value divided by the RMS value. This relationship can be used for both voltage and current. So, if we have the peak value and the RMS value, we can easily calculate the peak factor. Now look at section number 4, the peak factor of a sine wave. This part is very important. In a sine wave, we know that the RMS value is equal to the peak value divided by the square root of 2. If we substitute this relationship into the peak factor formula, the result becomes the square root of 2. Its numerical value is approximately 1.414. So you should remember that the peak factor of a sine wave is always 1.414. Now we move to section number 5, the peak factor of different waveforms. In this table, several different waveforms are compared. For a sine wave, the peak factor is 1.414. For a square wave, this value is 1. And for a triangular wave, it is approximately 1.732. This table shows that the peak factor depends on the shape of the waveform. Now in section number 6, form factor versus peak factor, the difference between two important concepts is shown. Many students confuse these two parameters. Form factor is the ratio of RMS value to the average value. But peak factor is the ratio of the peak value to the RMS value. Therefore, these two parameters have different applications. Now we move to section number 7, significance. In this section, the importance of the peak factor is explained. This parameter indicates the level of stress applied to the insulation of electrical equipment. Now in section number 8, applications, the practical uses of peak factor are presented. This concept is used in electrical measuring instruments, transformers, electrical machines, power electronics, high voltage engineering, and signal processing. Now we move to section number 9, numerical example. In this example, the peak value is taken as 325 volts. First, the RMS value is calculated, and it is found to be approximately 230 volts. Then, by dividing 325 by 230, the peak factor is calculated as 1.414. This example confirms the correctness of the formula. Now in section number 10, formula box, the main formulas of the lesson are reviewed again. This section is very useful for a quick summary and revision. And finally, we reach section 12. Exam tip. This is a very important point for students. Here's the exam tip. Whenever you face a sine wave in a question, you can immediately take the peak factor as 1.414. That's it. It's a constant. You don't need to calculate it every time. Just remember this number. 1.414. Now let's summarize what we learned today. At the end of this lesson, remember this. Peak factor is the ratio of peak value to RMS value. For a sine wave, it's 1.414. That's the square root of 2. And it's one of the most important parameters for waveform analysis. And for designing electrical equipment. Keep this in mind for your exams. And for your practical work. That's it for this lesson. Thanks for watching.